Right. So for learning objectives, the introduction to ANoVA test. So at the end of this class, you will be able to determine when to use the assumptions and steps in one-way ANoVA test. You will be able to perform data analysis of one-way ANoVA by using SPSS, interpret the SPSS output, what to report and present, and make conclusion from the analysis. Okay, so last week we have learned about t-test, one sample t-test, independent t-test, and paired t-test. You still remember when to use t-test, one sample t-test, independent t-test, paired t-test? Still remember?
Yes.
Yes.
Right. So when to use independent t-test?
When the variable is categorical.
Okay, what variable categorical? Dependent or the independent variable?
Independent.
Dependent.
Independent variables. Dependent variable in numerical must be in numerical. Okay. Can you give an example of independent t-test? When to use independent t-test? Anyone? Can you give one example?
Kalau nak check BMI between male and female.
Okay, good. Siti Nur Husna. So if we want to compare the BMI between male and female, we can use independent t-test because there are two groups of independent groups, male and female, right? Okay, and BMI is dependent variable, must be in numerical. Okay, for paired t-test,
Two groups must dependent.
okay. So yang lain pula jawab. Yang lain pula jawab. When to use paired t-test?
Two groups dependent.
Siapa ni? Okay, good. So for paired t-test, we can use to determine the difference between pre and post. Okay, good. So but the variable, the dependent variable also must be numerical. Okay, right. So we recall for one sample t-test, we can compare two means of one variable, which is we compare the mean in our sample with the predetermined value or the constant value. For independent t-test, we use to compare two means of independent groups. Okay, for paired t-test, we compare the means of two dependent groups or paired data. Okay. So for a one-way ANoVA, when to use one-way ANoVA? Okay, it is used when we have more than two groups that are also independent. Okay, if we want to compare or to determine the difference of more than two means of independent groups, so we can use one-way ANoVA. Okay, like I give you one example. Okay, if you want to compare the knowledge score between gender, male and female, we can use independent t-test, right? So we have two groups, male and female, we can use independent t-test. Okay, let's say if you want to compare the knowledge score between more than two groups. Okay, for example, between different programs in FSK. So we have eight programs, right? Physio, NAD, Opto, MLT, and so on. So if we have more than two groups, we can use one-way ANoVA. Okay, so we can compare between 8 groups or between 3 groups, between 4 groups. Then we need to use one-way ANoVA. Okay, so research questions involve comparison. Okay, many times research questions involve comparison of several groups on particular measures. Okay, if we interested in measuring the difference of numerical data among set of groups that there is more than two groups, we are dealing with different combinations of pairs of means. Okay, if we use multiple t-tests to compare different pair of means, we are running the risk of type 1 error. Alright, so if we have more than two groups, we can use multiple t-tests, okay, independent t-tests to compare different pair of means. But if we analyze using multiple t-tests, we are running the risk of type 1 error. Okay, instead of using multiple t-tests, we can analyze the difference among this group at once, simultaneously. Okay, so this test is called analysis of variance. Okay, let's say, for example, we want to compare the quality of life score between educational level. So we have educational level, we have 3 groups, okay, three level, for example, 3 or 4 level, SPM, diploma, degree, and master. Okay, so we collect the data, and then we want to compare the quality of life score between 4 educational level. So we can run t-test between the pairs. For example, we compare between SPM and diploma, SPM and degree, diploma and degree, okay, SPM and master, degree and master. So there are 6 pairs here. So we need to run multiple t-tests, 6 independent t-tests. Okay, so if run multiple t-tests, actually we are running the risk of type 1 error. So we cannot run multiple tests. Then we can analyze the difference among the 4 groups, okay, by using analysis of variance, by using one-way ANoVA. So you still remember what is the type 1 error? Type 1 error, type 2 error, still remember? What is the type 1 error? Anyone?
Type 1 error kalau kita terima 0.05 only.
Okay, so that is the significance level 0.05. So what is actually type 1 error?
Kita reject null hypothesis.
Okay, type 1 error is we wrongly reject the null hypothesis. Supposedly we cannot reject the null hypothesis, but we conclude from our sample, we reject the null hypothesis. Supposedly in the population, there is no difference or there is no association, there is no relationship, but we make the type 1 error, from our sample, we reject the null hypothesis. We conclude that there is significant difference, there is significant association or relationship. Okay, so if we run multiple t-tests, we are running the risk of type 1 error. Okay, so we need to use one-way ANoVA. Okay, so ANoVA test is a technique to identify and analyze the sources of variation in the dependent variables. Okay, in ANoVA, there are 2 variations that will be considered, which are within group variation and between group variation. Okay, within group variation is the dispersion of data within the groups, and between group variation is the dispersion of group means. Okay, both types add up to total variation. So within group variation means that the variation or the variability or the dispersion within the groups. Okay, for example, if we want to compare the group A, group N, group B, and group C, 3 groups. Okay, so the variation within group means that the variation or the variability among the samples within the group A. Okay, among the samples within the group B and within the samples among the group C. So whereas the between group variations means that the variability or the dispersion or the variations between group A and B and C, between the groups. Okay, so the ANoVA is computed by variance ratio or the F test. Okay, variance ratio equal to the between group variation divide within group variation. So by mathematically analyzing the variability or the variance of groups can tell us whether their means also differ. To determine whether the between group difference is large enough to reject the null hypothesis, we compare it statistically to the within group difference based on the F test. Okay, so F test equal to the variations among the sample means or the variation between the groups divide the variations among individuals in the same group, in the same sample. So the variation between groups divide the variations within groups. Okay. The larger the overall F test, the more statistically significant it will be, so that there is a mean difference between the groups if the F value is larger. This is the formula for F test, F statistics. F equal to the mean square between is the variation between the groups divide MS is the mean square within the groups. Okay, mean square equal to the sum of square divide degree of freedom. Okay, so this is the formula of sum of squares. Okay, and then this is the degree of freedom. So for ANoVA test, there are 2 degree of freedoms between groups and within groups. Okay, so between groups is k minus 1 and minus k. K is the number of groups and is the sample size.
Doktor.
Okay.
Doktor, kiranya kan kalau nilai F tu besar, kiranya kita boleh reject lah null hypothesis tu kan?
Yes, yes. If the F test is more larger, means that the p value is lesser. So we tend to reject the null hypothesis.
Alright, thank you, Doktor.
Okay, actually there are several types of ANoVA tests. Okay, one-way ANoVA, two-way ANoVA, multifactorial ANoVA, and other extension of ANoVA. Okay, one-way ANoVA is the univariate or bivariate analysis. Okay, other types of ANoVA like two-way, multifactorial, general linear models are multivariate analysis. Okay, so this one for undergraduate level, it is enough for you to just to know the one-way ANoVA. Okay. So for two-way ANoVA, multifactorial ANoVA, we deal with the more than one independent variables. Okay. So for example here, two-way ANoVA. Okay, for if you use one-way ANoVA, if we have only one categorical independent variable. If we have more than one, okay, we have 2 categorical independent variables, we can use two-way ANoVA. If we have 3 or more independent variables, we can use multifactorial ANoVA. Okay, other extension of ANoVA you can learn in general linear models like ANoVA, repeated measures ANoVA, mixed ANoVA, MANoVA, MANoVA, and so on. So there are many types of ANoVA tests. Okay, I give you example when to use two-way ANoVA. Okay, if you want to know the effects of educational level and marital status on quality of life score. Okay, for example here. So here you have 2 categorical independent variables which are educational level and marital status. Okay, educational level and marital status have more than two groups. So you can you want to analyze simultaneously both of the 2 variables and you want to check the interaction effect. So you can use multivariate analysis, which is two-way ANoVA. Okay. So, but if we have only one categorical independent variable, so for example, you want to determine the effect of educational level on quality of life score, then you can run one-way ANoVA. Okay, and then you run the effects of marital status on quality of life score. Okay, you use one-way ANoVA. So there are two analysis of one-way ANoVA here. Okay, boleh faham tak apa yang saya explain?
Boleh, doktor.
Okay, so data required for one-way ANoVA, you must have one numerical dependent variable. Dependent variable must be in numerical or continuous, and independent variable is categorical with more than 2 levels or 2 groups or 2 categories. Okay, so when we compare two or more means, we use one-way ANoVA. So the example here, the comparison of 3 teaching methods in schools. So we want to compare the students' performance. Okay, students' performance can be in GPA, CGPA, or other measurement. Must be in numerical. Okay, so we want to compare the students' performance between 3 teaching methods here: teaching A, teaching B, teaching C. So we can use one-way ANoVA. Okay, and another example is here we want to compare the patient's outcome using Bartle's index between 2 methods of monitoring head injury patients in ICU. Okay, current method in ICU A and modified method ICU B. So one-way ANoVA also can be used to compare two means, same as the test, but if we only have 2 categorical, if you have only 2 groups or 2 categories, actually independent the test is preferable because it's the test is more flexible than one-way ANoVA. So if you have two categories or 2 groups, we also can use one-way ANoVA, but independent test is preferable. Okay, and then also one-way ANoVA test is more suitable to compare the more than 2 means. Okay, example of a research question answered by one-way ANoVA. Research question to study the effect of 3 different teaching methods on students' performance. Okay, so example here we want to compare the students' performance between 3 teaching methods. Okay, 3 different teaching methods. Okay, so we use one-way ANoVA test to assess whether the mean of students' performance in score are significantly different among the 3 methods. Okay, so if the overall ANoVA test is significant, okay, if the F test is significant, it indicates that there are differences among the 3 groups, but does not tell us which pairs of group that are significantly different. So then we need to follow up by doing post-hoc tests to determine which pair was significantly different. Okay, assumptions in ANoVA test is similar to the independent test. There are 4 assumptions. Okay, first, random samples. Okay, and then the variables or the categories, the groups are independent. Okay, and then the normal distribution of the dependent variables in each group. And the 4th assumption is homogeneity of variance. Okay, equal population variance among the groups. Okay. If the data is not normal, then we can apply non-parametric tests. All of the assumptions you must remember. Steps in one-way ANoVA. Okay, based on this research question, study among office workers showed that they took 3 different types of breakfast bar, cereal, and oatmeal. So the research question is, does the mean age differ among them who take different 3 types of breakfast? So here we want to determine the difference of age among 3 different types of breakfast. So the dependent variable is age, and independent variable, the types of breakfast with 3 groups. Okay, so the first step is the hypothesis statement. Okay, you state the null hypothesis. There is no mean difference of age among office workers who have different types of breakfast. So the null hypothesis, the mean 1 equal to the mean 2 equal mean 3. Okay, alternative hypothesis, we hypothesize that there is at least one pair of mean difference of age among office workers who have different types of breakfast. And then we set the significance level and confidence interval. So usually we use the alpha, the significance level 0.05 with two-tailed, and confidence interval we set at 95%. Okay, and then we check the assumptions of one-way ANoVA. So basically the first and second assumption, random samples and observations are independent, we clear during the study design and sampling method. And then we check the assumption of normal distribution. Okay, we check true SPSS output. Okay, we check histogram and so on. And then for using Levene's test, so similar as the same as the independent t-test, we also check the homogeneity of variance using Levene's test. If all of the assumptions are met, so we can apply one-way and okay. So steps in the SPSS, you can go to the compare means, one-way ANoVA here. Okay, and then for dependent list, you can move the dependent variable, which is age, and for factor, actually, here is the breakfast. This is another data set. So for the factor is for independent variable, which is type of breakfast. Based on the research question, is type of breakfast, and then you can click to the options. You can tick for descriptive and homogeneity of variance test to check the equal variance assumption. Okay, just click continue and you will get the output. Okay, so this is the descriptive table, shows you the sample size, mean, standard deviation, standard error, 95% CI, confidence interval, minimum and maximum values. And this one is the test of homogeneity of variance, the Levene's test. Okay. Next, before you read the F-test, before you read the ANoVA test, you need to check the homogeneity of variance assumption. So, you look at the p-value here. If the p-value is not significant, then the variance are equal. Okay. So here the p-value is 0.778, which is more than 0.05, so it is not significant. We can assume that the variance are equal. So the assumption of number 4 is met. Alright. And then we can read the ANoVA table for the F-test. Okay, so here is the F-test, here is the p-value. And this one is the degree of freedom, sum of squares, mean squares. Okay, so if you remember of the previous slide, that the F-test, the formula for F-test, F-test equal to the mean square between groups divide mean square within groups. Okay, you can take the calculator, you can try to calculate manually, then you can get the F-test, the value F-test formula from the previous slide. So the mean square between equal to the sum of square, degree of freedom here, and for within groups the sum of square within groups divide degree of freedom within group equal to the mean of square within group. And then mean of square between divide mean of square within, you will get the F value here, the F statistics here. So degree of freedom pun sama, degree of freedom for between groups n minus 1, and here okay, here degree of freedom total divide degree of freedom between, okay, here degree of freedom total equal to the n minus 1. Okay, here is k minus 1, degree of freedom between groups k minus 1. Alright, so to make the decision, you can look at the p-value here. So p-value is significant, means that there is significant difference of age between different types of breakfast, but we still do not know which pair is significantly different, whether A and B, B and C, or A and C. Then we must proceed with post hoc test to determine which pair is significantly different. Okay. So if ANoVA test is significant, if the F test is significant, it indicates at least one mean is significantly different of the other means. Okay, and then further analysis required to determine which pair of means are unequal or are significantly different. So we need to proceed with the post hoc procedures or post hoc test, which is the post hoc test is the pairwise multiple comparisons test, the difference between each pair of means. Okay, examples of post hoc procedures. There are many post hoc tests, which are Bonferroni test, Chef test, Tukey test. Okay, all right. And then you can tick in the SPSS. You can tick the post hoc. Okay, post hoc here, and then you can choose the equal variance assumed. Okay, if you check the assumptions of Levinstein's assumption of homogeneity variance and the variance are equal, the assumption of homogeneity variance is met, then you need to choose the post hoc test within this equal variance assumed. Okay, so there are many post hoc tests, and usually we can choose the Chef test. The Chef test is most conservative post hoc test. Okay, other tests like LSD. LSD is most powerful post hoc test for comparison of three groups. Okay, and then Bonferroni also we commonly use for the post hoc test, Bonferroni test here, and Duncan. Okay, Gabriel. Okay, if we have unequal sample size among the groups, okay, we can choose Gabriel test. And if we want to compare with the control groups, okay, for example, there are comparison of treatment groups and control groups, then you can use donate post hoc test, and then you click continue. Okay, so this is the multiple comparisons, the post hoc test table. You can look at the p-value here, and here is the mean difference. Okay, significant pairs will be marked as asterisks. So here you can look which pair is significantly different. So if the mean difference there is asterisk here, means that it is significant pairs. Okay, and the p-value also is significant. So which pair is significantly different? Here is pair breakfast bar and oatmeal. Okay, look, there is asterisk, and the p-value is also significant, p less than 0.001. Okay, so here the pair between breakfast bar and cereal not significant. The p-value is more than 0.05. And okay, you look at this row, oatmeal and breakfast bar. Okay, ini sama dengan pair yang ke atas ni, breakfast bar and oatmeal, so the same pair. Okay, you look at the here, oatmeal and cereal. Okay, the mean difference ada asterisk, and the p-value is significant, less than 0.001. Alright, so based on the multiple comparisons, based on the chef test, post-hot test, there are two pairs significantly different, which are breakfast bar and oatmeal, and the cereal versus oatmeal. Okay, so there are two pairs significantly different. And then you interpret, okay, how to interpret and make conclusion. Okay, first you mention that the one-way ANoVA test was statistically significant in the significant effect of types of breakfast on age. Okay, then write the F test, the F value, and this one is the degree of freedom between and within. Okay, and then the P value is less than 0.001. This one is the eta square. Eta square is the effect size for one-way ANoVA. Okay, and then subsequent post-hoc analysis, the chef procedure suggested that the workers who took oatmeal as breakfast had significantly older age as compared who took breakfast bar and cereal. So you write the mean and standard deviation. Okay, so where to get the mean and standard deviation from the descriptive table. Okay, and then you can also mention, however, there was no significant difference between age of the workers who took breakfast bar and cereal. Okay, so this is how to present the table presentation for one-way ANoVA. Okay, so the variable is type of breakfast, bar or oatmeal, and cereal. Here is the sample size, here is the mean and standard deviation, and the F value, degree of freedom, the P value. So for the post-hoc test, you can write in the footnote. Here you buat kat sini the superscript KB. Okay, then you mention the pair that are significantly different, the breakfast bar and oatmeal, and cereal and oatmeal. Okay, are significantly different by post-hoc test chef procedures. Okay, this one is the how to calculate the effect size for the one-way ANoVA. Okay, so the effect size, the eta square, equal to the sum of square between, divide sum of square total. Okay, any question regarding one-way ANoVA? Ada apa-apa soalan tak berkenaan one-way ANoVA? Any questions?
Tak ada.
Tak ada, doktor.
Okay. Semua faham ya?
Doktor.
Okay.
Nak tanya, tadi doktor ada cakap kalau kita nak guna ANoVA ataupun t-test,
Yes.
kan dia punya apa tu? Dia punya variable kan lebih sama kan? So macam mana nak bezakan ANoVA dengan t-test tadi? Saya terlepas yang tu.
Okay, so kalau kita ada two groups only, okay, kalau kita nak compare between two groups kan, okay, actually kita boleh guna juga one-way ANoVA, tapi the t-test is preferable. So kalau ada two groups, basically kalau kita nak compare only two groups, kita guna independent t-test je. Okay. If we want to compare the three groups, then we can use one-way ANoVA. Boleh, Zahidah?
Saya yang tanya doktor. Syafiqah.
Oh, Syafiqah yang tanya. Okay.
Madam, doktor,
Yes.
tadi doktor kata kalau contoh result P tu salah satunya signifikan, lepas tu kita kena buat post hoc comparison kan?
Yes.
Kalau contoh kita buat dia tak signifikan. Tak payah buat post hoc comparison lah kan?
Yes, okay. So here kan kalau p-value of ANoVA test ni tak significant, so we do not need to proceed with the post hoc.
Okay.
Only kalau yang ini significant.
Okay, thank you Doktor.
Okay. Okay, so we can try do this exercise. You can open the dataset HPT, the same dataset for the last week. Okay. Okay, can you see the data, the data set? Okay, now we want to answer this research question. Does the mean BMI differ among different smoking status in 120 sample? Okay, we look at the data HPT. Okay, we want to compare the mean BMI between different smoking status. Okay, here is our dependent variable BMI. Now can you see the data? Boleh nampak ya semua?
Boleh Doktor.
Nampak.
So BMI is our dependent variable numerical, and our independent variable is categorical smoking status. So for smoking status we have how many groups? Okay, we have 3 groups. Okay, so if our independent variable categorical, we have 3 groups, automatically we can run one-way ANoVA. Okay. Okay, like example here for exercise. Okay, example you want to compare the mean BMI between exercise group. Okay, you check the exercise, the data of exercise. There are 2 groups only, and then you can use independent t-test. So this is independent groups, 2 groups. You can use independent t-test. Okay, now. Okay, first, what we must do first, before we proceed to analyze one-way ANoVA, what we must do first?
Check normality.
Check normal distribution.
Okay. Check apa? We check normality first, right? Okay, we must check the data.
Distribution.
Okay, normal distribution of the data. Okay. So you still remember how to check the normality of the data? Can you show me how to check the normality?
Explore.
Okay, we go to the explore. Ni Kalau tak ada orang jawab, saya panggil nama ya. Okay, we go to the analyze, explore. Okay, then
Dependent list age for subject.
okay, dependent list apa? Based on our research question, what is our dependent variable? Based on the research question.
BMI.
Okay, BMI. BMI is dependent. Okay, BMI is dependent variable. And the factor,
Smoking status.
yes, smoking status. Okay, so we move the smoking status to the factor list. We want to check the distribution of BMI for each group of smoking status. And then next,
Plots.
okay, we go to the
Display
plot.
both, tekan plot.
Okay, good. Then we choose
Histogram.
histogram.
Histogram. Click
Okay,
for histogram.
okay, and then we can also tick the normative plot with test. Okay, for the stem and leaf, we can untick. We do not check stem and leaf. Okay, and then we continue. Okay. Okay, so we check the histogram.
Histogram. Double click.
Okay, double click the histogram.
Double click.
Okay, we click the curve here to look at the normal curve. Okay, so for this group, for the perokok, smoker, normal. Okay, so this one. Okay, next, tidak pernah merokok. Okay, alright. So overall, this one is look like bell shape curve, right? So this one is normal. It's normal curve. And okay, this one for bekas perokok. So ini you confuse kan? Whether it is normal or not normal. Yes. Why the graph, why the histogram looks like this? There are only 2 bar here. Okay. And then this one is also normal. Okay, nice curve, normal. Okay, this one basically the shape is look like this because of the sample size. Sample size is very small for this group, n equal 4. Okay, yeah, only 4 sample for this group, so that's why the graph looks like this. Okay, but never mind. You can also look at the other methods. Okay, so here the p-value for Kolmogorov-Smirnov test. So for the bekas perokok ni tak ada p-value kan because of the sample size. So but for both groups perokok and tidak pernah merokok here, it's not significant. It's not significant. So it shows normal.
Normal distribution.
Normal. So we consider normal because the basically the 2 groups are normal, and then there's only one not normal because of the sample size. So we can just consider the data is normally distributed. Okay, then we can proceed to run one-way ANoVA. If the data shows not normal for all the 3 groups, okay, then barulah kita consider dia tidak normal. Okay, then we run one-way ANoVA. Okay, go analyze, then compare means, one way ANoVA. Okay, so for dependent list, BMI and factor, smoking status. Okay, and then you can tick the options. Okay, choose tick descriptive and homogeneity of variance test. Okay, for Levin's test. Continue. Okay. So we get the output here, descriptive table, test of homogeneity of variance, the Levin's test, and the ANoVA test table. Okay, so first we look at which table. Okay, the first thing, okay, sekejap ya.